response. So that's the presentation.
Okay, I think it's time anyway.
Okay, shall we use the blue sheet?
Make blue sheet, I'll start with them. No problem. Good afternoon and welcome everyone to the I2NSF meeting here in Bangkok. As it's somewhat late in the week, you've already seen this, and it applies here as well as all the other working groups. So we've got a charter, we've got a mailing list. Do we have a minutes taker? Thank you. And we need someone on the Jabber room, just to channel things, tell people what presentation we're currently on. Anyone in the Jabber room? Come on, people, we can't start without somebody being in the Jabber room.
Is anybody in the Jabber room?
Some people are,
Okay. And,
including some presenters. Brian, thanks for coming. Would you like to be a Jabber scribe?
okay, thank you.
Okay,
So
thank
much.
you.
And for
Okay.
for the minutes, please.
Yeah, if possible, use Etherpad. It's convenient,
Yeah.
and others can help you. Okay, the blue sheets are going around, so be aware that the blue sheets are then scanned and published online, so everybody can know that for the rest of your life that you have been in the I2NSF meeting at IETF in Bangkok. Okay, so we got all that out of the way. Yeah. Okay. Martin, so we've completed the working group last call on the applicability draft. We've adopted the new working group draft, the registration interface data model, and we need to make decisions about the following drafts if they're ready for working group last call. And yeah, flow protection, capability, NSF-facing interface, capability data model, consumer-facing interface data model, and the client-facing interface requirements. Okay, and we'll get to that later. And we've got our terminology draft and gap analysis. Okay, so this is the agenda. Any bashing? Nope, take that as a no comment. So let's begin with the hackathon report. Oh, why do we have it? Yeah, but first let me get the correct one. Yeah, so shouldn't allow so many. That's a share slides, that's wrong.
Hackathon. Right side.
Hmm?
This one?
This one? No. Oh, yeah, that's one. Okay. Yeah.
Okay. Hello. This is Jaeun Porjung from Sungkyuan University in Korea. Let me shortly report the last IETF 103 Hackathon I2NSF framework project. So this photo shows our team. We worked very hard last Saturday and Sunday. And also, as you know, one of our team was one of the winner team among 21 teams. So we had the snapshot. And also next day, Monday evening, there was hack demo happy hour demonstrate the hackathon project. So our I2NSF project, we demonstrated, implemented on top of OpenStack NFV environment for I2NSF framework. This time, we implemented I2NSF framework on top of OpenStack with NFV reference architecture. So 12 grad students, 4 professors, 3 universities, and 2 researchers from ETRI, Korea Telecom. So this is a poster. So this time, we want to integrate I2NSF framework into Edge NFV reference architecture using OpenStack. So the first one is how to design integration of I2NSF framework on top of NFV reference architecture. Secondly, life cycle management of VNF using OpenStack Decorator. Third one is service function chaining using OpenStack networking SFC. In the past, we just used the Mininet to prove concept. This time, we tried to implement OpenStack because we want to deliver our OpenStack project into internet industry. So the challenge was how to place the elements of I2NSF framework in NFV environment. Secondly, the lifecycle management. We want to show what is a reasonable procedure of security file translation and enforcement. The third one is the service function chaining using networking SFC, including the OpenStack. So this figure shows NFV reference architecture. You can see I2NSF user specify high-level security policy. That policy is translated into a low-level policy. Sometimes corresponding NSF is not active yet. In that case, security controller ask developer management system, we can say DMS, to make that NSF active. Sometimes we need to invoke in the NFV this using NFV infrastructure. So DMS has interface either course VNF or EM to VNF manager interface. That one is used to a lifecycle management. So this one is talk to Mano orchestrator, and then it allows the generation of VNF. And then this guy also talk to virtualized infrastructure manager to create corresponding VNF. Okay, and then it is delivered to that message. This one eventually register that access information such as IP address, port number, protocol to used by users high-level policy into a low-level NSF. Okay, so and then configure using netconf protocol. So we implemented this. So this figure is a highlight the previous here. So in terms of I2NSF framework, you can see I2NSF user, this is a security controller, this development management system, NSF. So this is the NFV OpenStack. And then right-hand side, this one is the Mano stack. So Mano stack manage VNF. So we have interface between security controller and DMS. And also DMS and also Mano, especially a VNF manager has VNF manager interface for lifecycle management. So this is the procedure to create. So we believe I2NSF is very good for cloud-based security service system. So this time, this topology used, you can see. left hand side, the mono. So VNF descriptor is used VNF the information described, and also using VNF forwarding graph descriptor, performing SFC functionality. So specify web filter and the time-based firewall. That policy is delivered to over consumer-facing interface, and security controller translate into low-level policy, and then with mono stack interaction, and then translate, and then figure out what is appropriate NSF, and then deliver that low-level policy over NetCom protocol over NSF facing interface, and then configure, and then making this chaining using networking SFC, and we can performing web filter or time-based firewall. So again, so we implemented our 3 interfaces according to our specification I2NS working group. Also, we implemented on top of NFV using industry de facto standard for cloud. So we believe our I2NSF is going right direction. So lessons from IETF Hackathon project, we proved our data-driven policy enforcement is good, and also we implemented and realized I2NSF in real world on top of NFV on top of OpenStack, and also the student had a good hands-on activity experience. So before coming to IETF103 Hackathon, in Korea, we had 2 internal Korea IETF Hackathon project. So we prepared 3 months after 102 IETF Hackathon. Yeah, so you can see student discuss, and then we have the brainstorm, and then we implement together. That's why we come here. We try to finalize 2 days hackathon project, and then we prepare for the demonstration. So this appendix is other information you can find, other video clip, and also open source is available in GitHub. So our I2NSF work is open to the society. Anybody can use our work. Thank you. Yeah.
So, question. Do you have the source code linked into the I2NSF wiki page? People can access them?
Oh, yeah, sure. The I2NSF wiki, yeah, sure. So I send the link to you, okay? Okay, thank you. Yeah.
Thank you very much.
Probably next up we need.
How do we do that? Press that button, right?
If he's in the room.
It is in the room.
Gabrielle, are you in the room? Well,
Yes,
if so,
you
need to raise your hand so we can get you
Hi,
to
hello.
present.
Hello.
Yeah, we hear you.
Okay, thank you. Well, okay. Good morning from Spain. Good evening from there in Bangkok. Well, as you know, my name is Gabriel Lopez from the University of Murcia. The idea of this presentation is just to present the changes from version 02 of the draft. So I'm going to go quickly to leave time for the coming discussion. So as you know, we are working in the draft to define an architecture for the SDN basic IPsec management. We define 2 cases, case 1 and case 2. The case 1 suppose that IKE is in the network security function, is running in the network security function. And in case 2, we suppose that the network security function doesn't have the IKE process. So in case one, the security controller is able to configure IKEY, HPD, and PAV elements to be able to establish the security association. And in case two, the security controller is able to provide the HPD SAD configuration to the nodes and be able to provide the configuration to establish the security association. The draft includes a jam model. The jam model have the elements to separately configure IKEY version 2, PAD, HPD, and SAD. Depending on the case, the network security function is running in case 2 or case 1 or case 2, then the network security function should be able to receive configuration from, in case 1, IKEY, PAD, and SPD, and in case 2, SPD and SAD. Just a quick summary of the state of the art. Regarding the changes from IETF from the draft 02, well, the changes are based in, next slide please. The changes are mainly in the security consideration section 9, where we have emphasized the necessity of a security association between the security controller and the network security function. And we have clarified the requirement that the security controller should never store any kind of cryptographic material, neither in case 2 nor case 1. And we have also improved the description of the security consideration for case 2. As you can see, the changes are not too big. In the case of the jam model, we have updated the IKEY version 2 model. We have included the element initial contact to allow the IKEY version 2 peer to send a notification, the initial contact notification, to the other peer in case of the IKEY node restart. And we have also included the configuration of the security association lifetime that will be able to manage IKEY, the short and the hard lifetime. So that's all the changes in the version 2 of the draft. And we also want to present the implementation that in which we are working now. We have a network security function implementation. Now is open source. You can find the code in this Git server. The implementation of the network security function node, the net2peer server, is based on the sys repo and net2peer 2 libraries. For the implementation of case 1, we are making use of a strong one, like IKEY software in the nodes. And in case 2, we are making use of the PFK version 2 library in order to configure the SPD and SAD entries in the kernel. The current implementation is able to test the basic configuration for cases 1 and 2, taking into account the host-to-host and gateway-to-gateway scenarios. We have also tested the key mechanisms described in the draft document. Currently, although we are working in the security controller implementation, currently this software, to test the software, you have to make use of the net2peer client in the controller, in the security controller, to send the configuration by command line. the best way to test the software is to make use of the Docker-based scenario. This is repo-need-to-bear2 CFG IPsec2. This project is able to set up the host-to-host gateway scenarios, and then is able to run the controller, and then you can configure the case 1 or case 2 scenarios. And from the controller side, we are also working in the implementation of a more autonomous security controller. It is not ready yet to be public. We have explored OpenDaylight and ONOS. The experience with ONOS is very good, not so much with OpenDaylight. And we are also working in Python-based implementation using the NC client Python library. And okay, the software is based mainly on the work of graduate students and undergraduate students. So any feedback is welcome, and if you want to try that, you have the contact information for any kind of question or comment or etc. Well, at this point, our next steps are that we think the document is ready for the working group last call. We need that the document what needs is to have a deep review of the model. So I think that the working group last call is the best way to proceed now. And at the implementation level, we are going to continue with the work in the controller side in order to get this more autonomous software, and also to implement the complete model, because now the implementation support the IPsec basic IPsec scenarios. And we have to test all the elements in the model and to test the advanced scenarios. And that's all. Do you have any comment, question?
Thank you. We have some people asking questions. Yo.
Hi, this is Yovnir speaking with no hats. I've just reread the draft, and there's two things I think are missing. Well, one is extraneous, actually. Looking at Appendix A, where the Yang model is, this seems to document a lot of encryption methods and lots of encryption algorithms, many of which are obsolete today. There's single desk there's MD5, and I think a lot of that should be pruned.
Okay.
We shouldn't do in 2018 something that configures a gateway to do DES. The other thing that's missing is sort of related is some way for the NSF to get the capabilities. So most single gateways don't support all this long list of encryption methods, and they might support a small subset, and there's no way for the NSF, for the SDN controller to retrieve the list supported by a particular implementation. Now, it's fine to say that we expect the SDN controller to know that to know in advance what is supported, but if that's what we decide, then it should be stated explicitly.
Okay, well, regarding the first comment, this is the kind of review that we expect once the draft in the working group last call. This is the kind of review that we need from the IPsec experts. Yes, of course, in the second comment, of course, the idea now is that the model is how to say that we have tried to reflect all the configuration elements for both cases, case 1 and case 2, always taking into account to the standard, to the IQ version 2 and to the IPsec standard. So the idea is to represent all this information in the model, and then obviously depending on the NSF implementation, it depends of how we apply this configuration in the NSF. Then some option could be supported or not, depending on the operating system, of course.
Hello, I have a question. Frank Xia, Huawei. For this SDN-based IPsec VPN connection way, I think the key distribution is should be an important part. And you have listed two cases in your draft. One is IKE version 2, and another is a centralized distributed way. I'm wondering, actually, it's possible that there are third way. For example, currently some draft is talking about to do the different exchange among the peers through the controller. So would you consider to describe this possibility in your draft, or it's already there? Sorry, I haven't read the latest draft.
Yeah. Well, yes, I fully understand your question. This is the discussion in the last meetings. We have tried to clarify in the draft in the security consideration the problem of the key distribution. We think that currently the draft is the more closer proposal to the standard. And of course, as we were discussing in the last meeting, in the last meeting, we agreed to analyze the mechanisms to introduce a Diffie-Hellman negotiation in the scenario in order to avoid this problem of cryptographic keys. And this was the agreement, and we were talking in the last month with the people from Cisco that make the proposal. But the reality, the truth now is that we sent a proposal from our side to David. We sent a proposal of how this Diffie-Hellman solution could be integrated in case 2 in our draft without too much disruption. That is, we think that is relatively easy to include this proposal. But the truth is that we have not received any comment or any feedback from this proposal until now. So yes, it could be improved, but sincerely, from my point of view, this proposal probably could have more sense probably in a separate document or try to integrate with our case sheet. Thank you.
Yeah. Hi, this is David Carroll.
Hi
David.
Gabriel.
So I sort of have to apologize. You sent me that Diffie-Hellman proposal, and I did not get proper comments back to you on that. So I apologize. But I wanted to bring up, I think Yoav's going to talk about case 2, and I don't know what he's going to say, but we've talked about the security implications before. One of the other issues that I have with it is scalability. So it is an entirely controller-driven state machine. It involves messaging down for inbound spies, followed by waiting for acknowledgements, then messaging for outbound spies, acknowledgement, and then removal of the old inbound spies and outbound. This synchronization is n squared. It doesn't really scale when you're looking at very large numbers of nodes. And I think the Diffie-Hellman solution you sent to us was also controller synchronized and suffered a lot of the same scalability troubles, which we were trying to avoid, trying to keep things at n complexity. So we can certainly discuss it on the list or offline or anything else, but I think we need to look at the scalability issues as well.
So Dave, you have a presentation. Will you be able to elaborate that so everybody can hear that?
I can,
Okay.
want to
Okay,
later.
let's do that.
Okay.
So next one's y'all talk about the issues with case 2.
Hi. So before I start this presentation, I want to say what it's not. It's not about us chairs telling you what the correct thing is. Not saying that case number 2 is good or bad. I just want to reiterate all the things that we've already heard, so that we don't repeat them in the discussion going on here. So I'll run through it as quickly as I can. Okay. So what is case number 2? The draft IETF103-I2NSF SDN IPsec flow protection, long one, describes 2 cases or modes of operation. The first is where the SDN controller provides the NSFs. NSFs is like IPsec gateways with SPD and PID. For those not versed in IPsec, SPD is the security policy, like what is the protected domain, what algorithm you should use. And PID is who are the peer authorization database. It's who are the peers, what credentials you use to authenticate them. And then the NSFs themselves set up the traffic keys using IKV2. Case 2 forgoes the PID and sends the SPD and SAD to the NSFs. That's again the protected domains and the traffic keys, actual traffic keys. Some of us don't like case number 2 very much. And what's wrong? Well, first of all, it's icky. That's the technical term. We don't like having traffic keys shared between 3 nodes. Benjamin Franklin famously said 3 can keep a secret if 2 of them are dead. And case number 2 adds a bunch of ways for the traffic key to leak. If the traffic key is ever inside the SDN controller, then the SDN controller can leak the key. The other thing we don't like is key transport. The connections between the SDN controller and the NSFs are supposed to be protected, usually using TLS. And we trust a TLS connection to transfer all kinds of information, including secret information, but not keys. We don't like key transport. So our ideal is to have keys generated, if you like FIPS terminology, within the cryptographic boundary and never leave it ever. That's the ideal. And we don't have that when the keys are transported from the SDN controller to the NSF, unless you enlarge the cryptographic boundary to include several servers. However, all these concerns are about a rogue or bugs in the SDN controller. And in an SDN environment, you really can't protect against a rogue controller. Suppose we have 2 NSFs, call them Alice and Bob, and they're using IPsec and they're using IKV2 because they're using case 1. And so what does the rogue controller do? It introduces Eve, and then it reconfigures Alice so that the domain that is protected by Bob is actually behind Eve, and it tells Bob that the domain that is protected by Alice is actually behind Eve as well. And what happens? This happens, right? So and it doesn't matter how securely they do the IK negotiation between Alice and Eve, because Eve is the wrong thing. Now, this is not such a weird thing. I mean, SD1s do that all the time. They measure the performance of connections between Alice and Bob and say, well, this is going a bit slow. And on the other hand, with the connections to central office are going great. So yeah, let's reroute it like this. That's part of SD1. That's a feature. It's not a bug. So it's not all that weird. And on the other hand, that thing is really an attack. I mean, if that happens all the time, and not just spurious network connections, then yeah, it's conspicuous. Somebody will notice. Whereas if the SDN controller just stores the keys, maybe for debugging purposes, in some networks, and then leaks them to someone else who's recorded the traffic, yeah, we would know. Well, on the other hand, we would notice if traffic is always routed through Eve. So sharing keys will not be discovered. This will, yeah. However, there's another thing, another layer here, or like layer 9, that sometimes we use IPsec for things like HIPAA, PCI, and then are they okay with key sharing? And they like us increasing the cryptographic boundary to envelop multiple servers. I don't know. This is kind of a FUD message. So everybody likes case number one. Why not just stick with that and be done? So we've heard some reasons, and they kind of sound like the IoT things, but claims, but this is not IoT. So the implementation is simpler if we don't package IPsec with it. But these days, everything has IPsec. I mean, everything Apple makes has IPsec. Well, not the watch. Everything Windows, including my phone, has IPsec. Every Linux distro has either StrongSwan or LibreSwan. So that's a weird argument. And the other thing is that small, cheap NSFs don't have either a random source or a time source. So they'll have a hard time negotiating IKE. But really, I mean, we said the connection to the SDN controller is protected. So it's protected with what? With TLS? You need all these. You need all of this for TLS as well. So that doesn't really sound convincing, but maybe some people are convinced. And as for case number two, well, obviously the best way to mitigate the faults in case number two is to use case number one. But the other thing is we have draft Cal IPsec ME controller IKE, which we'll see presentation immediately. It's somewhat of a midpoint. It uses Diffie-Hellman to negotiate the keys between the NSFs. Yeah. So the SDN controller never really gets the traffic key. It stays within the cryptographic boundary, so that's a good thing. And the controller does not even have the private keys, so they're generated on the NSF, so they just publish the public keys either between themselves or through the controller. And it doesn't prevent the man-in-the-middle thing, but then we've said that whenever you're in an SDN environment, you can't stop the man-in-the-middle. So yeah, discussion goes here. But we'll start with, okay.
I just, as a jabber scribe, pointing out that Raf is in the queue and he's been trying to talk.
Okay. Right now.
Hello there. Thank you, for your presentation and the comments. Seriously, I think you have described here an attack about if, and my point here in summary, and we already mentioned that in the past, is that of course we are assuming the SDN controller is a trusted entity. It's a key distribution center. It's a trusted entity. Of course, if you attack the controller, then you can do everything you want. That's clear, and I thought that was clear from the beginning. In the attack you mentioned, you said rogue SDN controller. So that means the Alice has not authenticated the SDN controller, or the SDN controller goes rogue because it has been attacked. Of course, what I say is I can imagine a lot of attacks if the controller is under the control of the attacker. That's clear, and we mentioned that in the draft and during our presentation. That's clear, because actually the NSF is an entity which hasn't control of anything, just encrypting the AB packets, and that's part of the of case two. I agree. I completely agree with you on one thing, in many things actually. But for example, you mentioned in the last slide, case one is clear. I like case one. You mentioned David draft. As Gabby mentioned, we already sent them slides explaining how to use Diffie-Hellman to avoid, the things we are discussing here, so the controller doesn't see any key. But what I can tell you, it complicates the design. Case two has a very, very neat and clear design, and it's easy to implement. It's clear. At the cost, of course, it's a trade-off. If the SDN controller is attacked, then you have a problem. That's clear, because it's a trusted entity after all. If it's not trusted in some point on the future, then you have a problem. But regarding that, personally, if instead of thinking about Diffie-Hellman through the controller and everything, in my opinion, use case one. Clearly, simple. It's very simple. And then you avoid a lot of problems we are discussing. So case one is clear. And another comment is about, you mentioned about the small chip NSF. I don't know, we didn't mention about the random source or time source or whatever, but the thing was, you mentioned TLS or SSH, and that's clear. That implies both entities are authenticated. I mean, Alice and the controller, or Bob and the controller. So everybody is fine with that. But that connection is used for many things, not just in our case. In our case, is to send information regarding IPsec. But that security association is used for many other things, for many other management, for routing, for any ways of configuration you can imagine in the SDN paradigm. So you're using one TLS connection for many things. And one of the things is to install configuration related with IPsec. So in my point of view, your presentation is pretty clear, because in summary, of course, case two is the SDN is attacked, then we will have a problem. We can imagine not only the case you mentioned, we can imagine a lot of cases. So I don't know what is the particular new aspect of this attack regarding to other aspects. I mean, that's my question. I mean, is this attack a particular attack, or just happened now, or because in the end, in my point of view, as I said, SDN controller is attacked, then no game.
Okay, this is all open to discussion. I just want to a little push back to what you said, that, well, trust is contextual. I mean, I trust you to send the slides on time. I don't trust you to take care of my 2-year-old baby.
Sure.
I trust the SDN controller to distribute configuration. I'm not sure I trust the SDN controller to store and delete on time traffic keys, which may leak a lot later. So it's good to limit the amount of trust that we have in a particular implementation of the SDN controller. Okay, now I'll cede the floor and let the discussion go on.
Okay, my name is Gujun from Nokia. So I just want to express I'm one of those guys don't like case 2 or even case 3, like this control-like stuff. So I think the thing I don't understand is that if we already have case 1, which seems everybody agrees that's the most secure solution, why do we need to have case 2 and case 3?
Oh, that was actually described in the document, so you can look at it.
Maybe can somebody explain that why there need to have additional cases? If the case 1 is perfect. For me, it's just I don't see any value or advantage of case 2 or case 3 compared to case 1.
Oh, okay.
The value is supposed to be simplicity. So.
Simpler because IP is mature protocol. It's deployed for many years in the field. So IPv2 has been developed many years and been deployed many years. It's mature. It's field proven. Everybody knows how to do IPv2. Now, why do we reinvent the wheel here?
Valery Smyslov, Elvis Plus. I'd like to focus on concerns that I haven't seen here in your implementation. So just to be clear, I don't like case 2 also, but I'd like to raise another issue with it. So I think that most people claiming that IPv2 is simpler and is very simple, clear, and easy to implement, focus on creating of IPsec assays. But they don't forget that IPsec assays need to be rekeyed, need to be deleted. And sometimes this must be happened in real time on the events that happen in NSF. So in case 2, controller must have a real-time picture and behave not only distribute configuration, it must behave in real time, getting events and take into consideration a possible delays of these events, a possible failure of links between controller and NSFs. And all these may complicate and make the whole picture unreliable, less reliable than in case 1. So in ideal world, when we have no delays, no failures, everything works well, probably it will be easier, case V2. But in real world, I think that, well, it may get very complicated compared to case 1. Thank you.
Yeah, David Carroll, to respond to the comments that we know Ike V1, or we know Ike, why don't we just do Ike in case 1 and not case 2? Having built and deployed really large SDN networks, we found Ike V2 didn't scale the way we needed it to. And so we went to a model of using a central controller to distribute keying material. We probably didn't do it the best way in our initial attack, but we've come up with a Diffie-Hellman-based approach that scales to the way we need it. So there is implementation observations.
Yovnir with no hats. I'd like to mention that there are already SD1 products on the market, and they usually follow the pattern of case 2. They're much closer to case 2 than anything in case 1. So we might like to take that into consideration.
Do you mean more close to case 2 than case 1?
They pretty much distribute traffic keys.
Yeah, actually, I saw some website describing that. Okay.
Hi, yes, Gabriel again. So just to comment to respond to a few comments. Can you hear me fine? Yes. Okay.
Now, better now.
No, it's okay.
Yes. Sorry.
Yeah.
Sorry. Well, the first comment is about the motivation of case 2. In this case, I completely agree with the job comment. The other comment is about the problematic of the key distribution and the security of the security controller. It seems to me that what we are questioning here is the SDN paradigm itself, because if we are concerned about the key distribution of the security controller, we also have to be concerned about the distribution of firewall rules, network configuration, routing tables, because all this information can lead to very security issues. So I think that we are all in this working group try to agree that the security controller is a key central point and that has to be a trusted entity. If we don't get this premise, then it's difficult to keep not only case 2 but only case 1, because the problem of key distribution is also in K1. A road controller should be able to configure weak asymmetric keys in the nodes, and so the problem of the security will arise also in case 1. So I think that we have to clarify that the security controller has to be a trusted entity, in the same way that the Kerberos KDC is a trust entity, because they are distributing not only key cryptographic keys, but only important configuration for the network and for security. And the last comment is about the concern about the security controller has to have the whole view of the network under its control. And of course, we are talking not a problem of the IPsec, but the problem of the SDN paradigm. We assume in the SDN paradigm that the security controller has to have a whole view of the network, depending on the role of the security controller. But if we are talking about a security controller for network traffic, we have to know the topology. At level 2, we have to know the router, we have to know the switches, we have to know the IP addressing. So in this way, it's the same. Security controller have to have the whole view of the network. And that's all. Thank you.
Or is
I have similar comments than Gabby's. Just one additional, one regarding to transporting keys from the controller to the NSF. As you know, there are a lot of secure key transport protocols. You can implement that actually when you send the key. Actually, for example, you can wrap that, the key you want to distribute, in some information, some token or whatever. So, of course, when we are saying we are distributing keys through a secure channel, we are assuming that every security is in place to avoid discover that cryptographic material that is sent through the channel. Otherwise, of course, if that channel has a security problems, keys will be discovered anyway. That's clear. Imagine also NSF in the same nature. You discover an attack in one NSF, you can apply the same attack to every NSF you contact. So you can discover every key in the network. You mentioned also, Joab, in the slide number 4, you mentioned that keys should be generated and stored within the cryptographic boundary. But in the case 2, especially because of the condition of the NSF, the cryptographic boundary is everything. I mean, it's the controller and the NSF. In the case 2, it's not the case because somehow the NSF has some kind of autonomy to create it in their own. But we are assuming in case 2, it's a very limited NSF. That's the comment. Thank you.
Okay. Tero Kivinen. I had lots of comments earlier, but one of the things is that in case 1, even if the controller is completely trying to leak out information as much as possible, it still can't leak out the traffic keys between the 2 nodes. It can change the authentication keys to be wrong or very weak, and it can then make a man-in-the-middle attack like you were describing. That we can't prevent because you can configure the authentication keys. But he can't do that without, giving a weak, authentication key or giving out the authentication to the man-in-the-middle person, which is, active attack on time. You have to do that. He can't do that afterwards. He can't, there was some traffic 3 weeks ago that I want to pre-crypt. Okay, I will go and pre-crypt it. He can't do that because he needs to do that on the fly while those 2 nodes are talking. If we have a traffic key stored in a case 2, there's nothing preventing the, this node, putting some, let's say he have a flash where he stores the information, and everybody knows flash is impossible to destroy. The keys are there. When you write something to flash, it doesn't destroy the stuff that is already. It just allocates a new block and writes stuff there. And this one goes on. So it's actually very possible to, recover that information back there, even if it's supposed to be deleted. So 3 weeks later, you can come in, take the box, find out the traffic keys, and decrypt the old traffic that you stored 3 weeks earlier. Or all the traffic that you actually, because you stored all the traffic. So that's actually allows, even, and also the same thing is that the security is very different because in most of the cases where if the controller is compromised, what he can do things right now. He can do, attack things, modify the stuff but he can't do anything that was happening before this attack, before he gained access to the controller. But if with the case 1, he still can't do anything. But with case 2, he might be able to do that. That's the the difference there is when is the attack happening, and is it easy to detect? I mean, man-in-the-middle attacks are usually something that you can detect. The controller giving out the keys to some extended third party, with having 3 letters in the name, is really very hard to detect, especially if when you buy the product, you don't know if it's actually giving out those keys. And there's no way of knowing. Let's put it this way, this controller is made in China. Do you actually trust that the keys stay in that? Or if it's made in US, do you want to use it in China? Because you pretty much sure that know that, okay, the keys are going to be leaked out. If it's, in this kind of case 1, you can't leak the keys because the keys are in the boxes and they never leave them there. Yes, man-in-the-middle you can do, but you can't leak out the keys.
Would just want to reemphasize that my point that I think there's a difference between that trusting a controller, a central point, and then there's minimize the impact once the controller is compromised. I think, of course, we agree that you have to trust the controller to give you the configuration of information, but which is different that if the controller is compromised, we should have minimum of impact to our traffic. I think that's the difference.
The thing is, I think, my opinion, this comment has been done in the past. For example, I know there are a lot of 3-party key distribution protocols, and they are secure. Of course, that 3-party key distribution protocol, one of them could be Kerberos. There are a lot of them.
Rafa, your mic is cut out. Okay. So perhaps. So David, do you want to do your presentation? Yeah, real fast because we're running out of time.
All right. So
clicky's over there.
sorry, it says case 1 up there. That is a typo. I have nothing to say about case 1. Case 1 is fine. Case 2. So we looked at case 2 and what it's doing. There's a lot of traffic. I was talking about this. We send the inbound spies from the controller to both NSFs, then you wait for a response. If one of those goes offline in the middle, it's the job of the controller to go clean up. He has to go delete those the inbound spy, at least from the other NSF. Assuming there is no dropout, everybody responds. Now, once the controller gets that, his state machine sends outbound spies to both NSFs. Again, wait for a response. If somebody drops out in the middle of this, go back, clean up. Third, now you have to go and delete the old spies. It gets busy. What have we done? We've created 6 times n² messages for the controller and for the NSFs. We're having a lot of traffic in a large network now, simply for the purpose of setting up our keying. We're not even sending data. We've created n² state machines on the controller. That's a lot of memory getting used. It's very large. It brings up these reliability problems. If your controller crashes, you've got to go clean up all that state. Remember, in this model, the controller is cleaning up all the spies and the SAs. We've got to go back and clean that up. What about multi-tenancy well, all right, so I'm getting ahead of myself, sorry. Multi-tenancy I put up there just escalates the whole problem. Going back to the reliability, what do we do if we want to have multiple controllers? We'd love to have redundancy. Now you've got to have this very tight synchronization between your controllers. And we have network models where some of the NSFs talk to one controller, some of the NSFs talk to a different controller, and they actually don't have live connectivity to the same controller. Trying to synchronize all that in a case 2 in this doesn't work. Let's see, gets more complicated. Great. So here I drew up messaging for 3 hosts. It gets insane when you start getting up to larger numbers. Other issues, I mentioned multiple controllers. We've all talked about the IPsec keys. We don't need to go into that. We looked at the configuration models. So case 1 is sort of typical RFC 4301. You're sending an SPD and a pad information to the NSF. The NSF is generating the SAD, and he's going to report back SAD messages to the controller, but basically for accounting purposes. How many bytes, how many packets, all that stuff. Case 2 changes it, and it goes to a completely different model. We would be looking for a model that was more similar between them. It'd be nice to configure whether you're doing case 1 or case 2 more the same way. So controller Ike, we've talked about it before. It hasn't really changed, so we've gotten some comments, and we're going to put a new draft out. We've started working with the EVPN folks, and we're going to try to integrate some stuff there. But what do we have? We have n messages for the controller instead of an n squared. And actually, this gets less than n if you're talking about individual messages, because you're grouping them together. Controller doesn't need to send out an individual rekey message for every node. They can lump a whole bunch of them together when they're distributing them to other nodes. It creates one message to the NSF as opposed to n squared messages. And this is everything is per rekey. Every time you rekey, it's another n squared, or in our case, another 1. No state machine on the controller. This makes recovery really easy. This makes redundancy very easy. It's a design we think is better for an NSF. I'm sorry, for an SD-WAN. Multiple controls easy. Controller knows no IPsec keys. We talked about that. We do the configuration model much more similarly to the case 1. You're sending an SPD and a pad down. You're generating a SAD on the NSF. You're sending it back up. And I mentioned before, it's very robust to things going offline, either the NSFs, the controllers, any of those, they all happen. This is our packet flow. Very, very simple. The idea behind what we did in controller Ike is very loose synchronization. So our purpose is, nodes respond at different times. We don't want to be tied to any requirement that when A wants to rekey, B has to be online or has to be ready. It's very loose. It's even loose enough that it really supports most data plane, control plane models, where your control plane may get the data, control plane on an NSF. At the point that the data plane synchronization happens, really could be an extended amount of time or not. Obviously, you can't extend past key lifetimes, but we're not talking that size number. We're talking just very loose synchronization. We have no packet loss. There's no point where you don't have the right keys and you're not able to either send or receive traffic. And also rekeying. A will rekey at a different time than B. We just know that this will happen. Doesn't matter. That's all handled. That's all. We'd like to do more with controller Ike and.
Yeah, I'll let Rafa respond and but then we're going to have to cut this discussion because we have about an hour worth of presentation and 25 minutes left.
Okay. Anything?
Okay. Regarding for example, I don't know the number of the slide because it's not there here, but basically the algorithm we have in the draft is let's say the safest mode in our draft. I mean, the safest mode saying, okay, we install first the inbound, then the outbound, and everything. Actually, you have something in your draft where everything inbound, outbound are installed in the same time, and I mentioned you that will require most probably changes in the kernel, in the actual implementations, and we didn't want to assume that, and that's why we follow actually the right procedure according to the real work of the kernels we have seen. That could be optimized, yes, that could be optimized. So the number of messages will be less. That's one comment. In my opinion, if instead of using, personally, I think case one provides all the features you are describing here, and it's already there. So in my personal opinion, is case one or controller Ike, my personal opinion. For me, case one is the right one. You don't need to change that. You use Ike and everything. So another comment that I have, as Gabby mentioned, actually we designed case two internally. You know that. We send you the slides. We can also send the slides to the group if that is interesting for them, so they can see how we changed the case two. We did the exercise to include Diffie-Hellman, so that the controller doesn't see any key. But as I said, if you go on the scalability, I don't agree that Ike version 2 doesn't scale. It's everywhere. So that's clear. So it's not this against case 2 or case maybe, I don't know. It's if we use case 1 or maybe we use controller Ike. To me, clearly, case 1 it's better because you don't need to change everything. It's already done. You send the configuration to Ike. You don't have any overload in the controller because everything is using Ike. So nodes are exchanging messages to Ricky and everything. You send the configuration, and the controller can have free time, let's say. So not sure. In my opinion, if looking at your proposal, I would prefer case 1. Thank you.
I think definitely case 1 has to stay.
Absolutely.
Actually, I have a. I feel like whatever been discussed here will be very useful for the industry. Like I'm sure there'll be vendors coming up with case 2 because it's obvious, and it'll be nice we document what y'all have. If it combined with their draft will be fine, but it has to be documented in a place. Maybe
they're the biggest manufacturer. Cisco.
Okay.
Would it make sense to write up a case 3?
Yeah, absolutely.
And then people can decide, do we keep
Whatever
1, do
Intel
we
is
keep
doing.
2, do we keep 3?
That'll be better.
I'll send something to the mailing list. Not a draft, just a quick little
Okay.
write-up of some text that could be inserted if people chose to, if they wanted it.
Okay, that'll be good.
So with that said, I have 2 questions for the room before we go to the next part. First is, well, it seems that we've not finished the discussion. There's more to say. So would people be open to having a virtual interim in about a month's time?
It'll be Christmas time.
Before Christmas,
Thanksgiving.
mid-December, around mid-December or January.
Okay. If people,
People,
actually, if Dave can put down that description of case 3 and the case 3 to be added, and you write down the problem with case 2, we can combine all of them together. That would be very useful document.
okay.
I can send also the slides that I have about the integration of case 2 with Diffie-Hellman.
Okay, so I'll send a message to the list about when we can do the virtual interim. And the second question is specifically to the IPsec people here, Dan. I'm looking for a volunteer to go over Appendix A, that's the Yang model, and recommend what we need to prune out of it. Single DES with 32-bit initialization vector is a prime candidate. And so whoever volunteers to do this will get a beer in Prague. So there's a good incentive. Free beer, Prague.
Yeah.
Anyone?
You have to double that offer.
Yeah. 2 beer. Okay. I'll send a message to the IPsec list about that as well. Okay, so next up is the capability development plans.
Yes,
Yeah.
the information model and the data model. Okay, I think we don't have so many time to left, so I try to keep it short. So this is about a new version of our capability information model. So this is okay. Sorry. Yeah. Okay. So actually, the basic idea or the basic content that does not change too much comparing to the previous version. We just do some reorganization. So so I just try to give a very quick recap of the basic concept or in this draft. So in this draft, we propose the concept of what is the capability and how we use the capability to construct our security policy and to represent what is a capability algebra. This is a calculation method to combine different kinds of capability to represent a network security function. So this is the whole idea of this draft. So there are a lot of information model in this draft to clarify what is the capability and how to use them to construct the policy and the different components in the policy. For example, we use the ECA model. ECA model is that we use events, conditions, and actions as a basic constructor for the policy model. And we also have some way to combine them to use for the security policy. So here, so a lot of details you need to look into the drafts. For saving time, I cannot go into detail. But here, one point I want to mention is that we are always considering if we can consider the use decorator mode for our information model and data model, because it may help the policy to be more dynamic, be managed flexibly. So what is a decorator model? It's a classical class model in our model design. So which means that for our network security function, we can add some security capabilities in real time, and in real time and with the attributes of the capabilities. So that means that the security policy can change when the network security is running anytime. So this is very flexible. Okay. So a lot of content text describe how we use the YARN model as an example to give a detailed description how to achieve this goal. So please take a look. And like what I said, actually in this version we don't change too much the real content of the previous document. We just reorganize the section because we think that for example the section 3.4.1 and .2.3, they are three very closely related sections to clarify how to construct a security policy rule and all of the key components. So we arrange them as three sections together, and then we move the other sections together because they represent the capability algebra and how to use them. So I think current structure is more logically clear than the last version. And we also want to add an appendix content to clarify how to base the current information model. We use the concept of the information model to help the data model design. So I think so. Those updates will reflect in the next version. It's a 0.5 version. So we think that maybe after we finish the next version, I think this draft is relatively stable. So maybe we can consider the WGLC. So okay, that's all.
We probably only have time to go through the working group draft, the personal draft to be discussed on the mailing list.
Which is the next?
Data model.
Consumer facing.
He has one draft.
Yeah, tab one. Yeah, exactly. So this is Jae-hoon. I present shortly for our working group data model draft. So basically, I think the Frank, the information model, I pretty good stable stage. Maybe another around, I believe, yeah, working group score is reasonable. So based on that, our base young data model, the Sue, Harris, and me with my student Jin Young. So also this base document the other consumer facing, NSF facing are pretty much, I think, in terms of data security services, except, so Frank and I discussed the Cataldo, John Strassner suggested some decorator design pattern. If they provide some example, we try willing to reflect, except that I think it is good enough. So we verified our data young model last 7 hackathon projects. So it is working well, even though on top of NFV, we prove concept. So I think this time we try to address advanced security function, antivirus, anti-DDoS, and intrusion protection system. So we can plug in easily accommodate a new advanced NSF capability. So the draft done is either pretty good because our NSF pacing and capability can willing to accommodate easily. So I believe we can separately work for advanced security draft. So this is accommodation. We can easily accommodate the new advanced NSF. So this is our extension for that. So next step is we try to decorate model reflected, I believe, working with score this December. Hopefully we can pre done. The secondly, NSF facing interface. Frank gives a good comment. So Melon is already we discussed, right? So 3 comment already resolved. So we reflected system policy for multiple system policies, 1 NSF. Also, we deleted aggregate pointer attribute, just we using container. And also we adding a policy usage time according to priority. Okay, giving a number of, the policy we have prioritized order over number. So next step also again, we can reflect the decorator pattern. We can do working rest score. And consumer facing also, the major change is we can accommodate threat seed using sticks and text. So sticks is for structure, threat information expression. Another standard group, OASIS. So we can accommodate the signature of the antivirus. So I think this is also pretty much done. So we a major change, we can accommodate the sticks description. Also, we try to reflect the decorator pattern. We can working with score. The last one is the restoration interface. Recently, the Diego Lopez gave some comment. So we implemented NFV reference model. So I explained the hackathon project. So this is the procedure. Working group take a look the cases. So Diego Lopez comment is there is no direct communication channel between security controller and DMS. However, we implemented our hackathon project. You can see we have restoration interface between security controller and developer management system DMS, and DMS and NFV manager has VE VNF management interface. We believe this architecture is reasonable. So I want to listen to our group's opinion. So we need to reflect Diego comment or not. So we have another document address life cycle management for I2NSF NSF on top of NFV. So please take a look at this new draft. Okay. So this is just the Diego comment. So also we include decorator pattern. We try to another round of the revision. I think that this one also we can working on rest score. Okay. Thank you. Question, comments?
I have a question. Has those gone through the young doctor to get reviewed?
Young doctor, not yet. So probably we arrange and then I think of the before during the working group course, some doctor can review our model carefully. Okay. Okay. Thank you.
We have 15 minutes left. So, do you have 3-person drafts? Monitoring.
So the monitoring case, and the Frank discussed how to the merge or whether to merge. So I believe we can. My opinion is I'm willing to merge the information model, data model, current data model, reflected important part of information model. So. And also, additionally, we explained the association among 3 major interfaces: registration interface, consumer facing, and us facing. So we explained. So the policy monitoring point of view, consumer and us facing involved. And then life cycle management or load balancing case, NSF registration interface can be used. So that one is additional content. So we try to accommodate the decorator pattern and try to resynchronize the latest Frank draft, and also the information draft, information model authors and our data model also needed to how to merge. We need to decide, and then hopefully this one can be adopted the working group document. So thank you.
Any questions? No? Let's go to the next one, the security object.
Jessica from Huawei. This is the 3rd time that we present security object in I2NSF working group. Next, please. Okay. Thank you. So first, a quick recap. This draft, as you can see on the bottom of this slide, this draft provides a set of commonly used policy objects, and it can provide reusability and simplicity when you're creating policy rules or making modifications. And a brief response to the chair's questions. This draft, although we only mentioned that policy objects can be used in NSF-facing interface, actually, the defining the objects can also used in the consumer-facing interfaces. And as for the relationship with the NSF-facing interface data model draft, actually the NSF-facing interface data model draft is about the framework, how to construct the I2NSF policy rules. And my draft is mainly about the detailed definition of each policy objects. So we keep this draft as a separate part and suggest the other data model authors to reference our defined policy objects. So here comes, we want to hear about the working group's opinions. Do you suggest to use this policy objects in other data model drafts? And as this is the 3rd time that we talk about this draft, is it a good start to be adopted? So, and we also warmly welcome your comments. Thank you.
So how many people have read the draft? Okay, so asking the question of whether it's a good start and whether we should adopt it is a bit premature in this case. So I'll ask people to read it, and we'll discuss it on the list.
Okay, thank you.
Any clarification questions? There.
Okay, the next one is the ASF, Advanced Security Function. configuration.
Hello everyone. I'm Wei Pan from Huawei. Today I will introduce our draft, the configuration of advanced security functions with I2NSF security controller. I will introduce the motivations of our draft and the relationship between our draft with the base NSF facing date model draft. We consider the base draft defines the architecture of the NSF facing interface, and our draft is the additional enhancement and supplement. In the base draft, it defines the action part, and it contains several advanced security functions. And in our draft, we want to further define the detailed configuration model of these advanced security functions. And this date model cannot be only used for the NSFs. We consider it can also be used by the other devices like switches and routers. The reason why separate the base draft with our draft is to prevent the base draft from being too long, and the focus of our drafts is different. The base draft focus on the architecture, and our draft focus on the advanced security functions. So that's why we separated them. The next is the antivirus. We have chosen, for now, we have chosen three most common advanced security functions in our draft: the antivirus, the anti-DDoS, and the IPS. For the next is a brief of our three functions. First is the antivirus. You can see in the right the yellow lines. We define the functions in the profile name, and it can be related to the action part in the base draft. And we so I will not I will just have a brief introduction. The anti-DDoS and the IPS are the same. And about the future work, we want to optimize the existing configuration parameters in the date model and include more security functions. We will also consider how these profiles can be referenced by other devices.
Do we have time for questions? Real quick one, Brian Wise, Cisco. One thing that kind of worries me about the advanced policy that you're passing is I don't think there's any standards developed for signatures and DDoS, and well, whitelists might be obvious, I don't know. But I think it'd be important to be able to reference the type of data that's being passed so that more than one vendor could use it. And that would sort of require having a standard for those policy options.
I have a question. When you say reference, where are the references? Can you elaborate? You said you need to reference something for those advanced.
Well, for example, what's the format of an antivirus signature?
Oh.
Right. Okay. Both sides have to understand, the controller and the NSFs both have to understand that. So you probably need a standard for an antivirus signature. And I don't know if such a thing exists. That's not my area, but I don't think there's one. So you might need something like that.
Okay, sure. That's right.
Translation.
Yes.
Hello, I am Jin-Yong Kim, a student at Samgyungan University. This presentation is about security policy translation. Why do we need security policy translation? In I2NSF, there are different security policy level specifications between I2NSF user and NSF. For example, users send security requirements such as high-level policy or without considering NSF, but because the NSF cannot understand them, NSF need security process to operate in their system. This is this provide guideline for security policy translation. Similar standard there is RFC 8075 from core working group. This is the translation process by mapping. You can see detailed process in appendix and report. We will receive comment. We want working group adoption code.
So let me shortly. So this one is the major question: why we don't have this one? So the COEP A75 RFC is a guideline for mapping HTTP to the COEP protocol. In the same way, high-level YANG the policy to the low-level YANG policy. I believe this is a good the guideline for implementation for our industry. So please, the working group, read this draft and then give us a comment. Thank you.
Thank you. Thank you very much. Okay, so I guess that's the end.
Yeah, yes. Yeah, that's what we got. So thank you all, and make sure everyone has signed the blue sheets. If you haven't, the blue sheets are right here. And thank you, and see you in Prague. And probably I'll talk to you in the virtual intern meeting. Thank you all.
I really do.
The controls doesn't work.
Control. No, it doesn't work.
No,
I did, instead of copy, I did a paste.
Oh.
And then